Hello, 6th graders. Welcome to Big Ideas Math, 6th grade math, section 3.1, Algebraic Expressions lesson. Pause while you write section 3.1 lesson in your math notebook. Pause while you write today's lesson objective in your math notebook. Today's objective is, I can evaluate an algebraic expression containing a variable by completing Big Ideas math practice with 100% accuracy in multiple attempts. Today we'll be starting on page 112 in your textbook. At the top of the page, we're reminded that an algebraic expression is an expression that may contain numbers, operations, and one or more symbols. Parts of an algebraic expression are called terms. Even though you wrote all of the definitions in your notebook during our last lesson, this is a really good graphic to copy into your notebook. So take a minute and pause and copy this with all of the parts labeled into your notebook. Now let's look at example 1, identifying parts of an algebraic expression. We'll start by looking at the study tip. A variable by itself has a coefficient of 1. So the term y in example 1b has a coefficient of 1. So let's start by looking at 1a, 5x plus 13. So the terms are 5x and 13. So those are the parts of the expression. So the coefficient, the number next to the variable, is the coefficient, and that is 5. And the constant is 13. So that's a number that doesn't change. That's what constant means. It never changes. It's always going to be 13. Now let's take a look at example 1b. 2z squared plus y plus 3. So the terms, or the parts, are 2z squared, y, or 1y, and 3. So those are all the terms. And then the coefficients, the numbers stuck to the variables or multiplied by the variables, are 2 and 1. And the constant, the number that's never going to change, is 3. Now let's move on to example 2, writing algebraic expressions using exponents. Write each expression using exponents. Because d is used as a factor 4 times, its exponent is 4. So d times d times d times d equals d to the 4th power. So this is just like we do with numbers, only we've got a letter instead. And then we have 1.5 times h times h times h. Because h is used as a factor 3 times, its exponent is 3. So we have 1.5 times h times h times h equals 1.5 h to the 3rd power. So 1.5 becomes the coefficient for h. Now we're going to move on to evaluating algebraic expressions. And when we evaluate an algebraic expression, we substitute a number for each variable. Then we use the order of operations to find the value of the numerical expression. So let's look at example 3, evaluating algebraic expressions. Letter A, evaluate k plus 10 when k equals 25. So we substitute 25 for k. So k plus 10 equals 25 plus 10. And 25 plus 10 equals 35. So we added 25 and 10. Letter B says evaluate 4 times n when n equals 12. So 4 times n equals 4 times 12. So we substituted the 12 for the n. And then we multiply 4 and 12, and we get 48. Example 4, evaluating an expression with two variables. So it gets a little bit trickier here, and you have to really pay attention to which variable is your A and which is B, and where to put your numbers. So we have A divided by B equals, and we substitute in 16 for A and 2/3 for B. So A divided by B equals 16 divided by 2/3. And we know to multiply by the reciprocal of 2/3, which is 3/2. So 16 times 3/2 equals 24. Example 5, we're evaluating expressions with two operations. So we're going to evaluate 3x minus 14 when x equals 5. So 3x minus 14 equals 3 times 5 minus 14 when we substitute 5 for x. 3 times 5 equals 15. So we have 15 minus 14. So we use the order of operations, and we multiplied 3 and 5. And then we subtract 14 from 15, and we get 1. So the value of that expression is 1. And then we're going to evaluate z squared plus 8.5 when z equals 2. So we substitute 2 for z. So 2 squared plus 8.5, and then we multiply. We do our 2 squared first because it's the exponent. So that turns out to be 4. And then we have 4 plus 8.5, and 4 plus 8.5 equals 12.5. Finally, we get to example 6, the real-life application. We're saving money to buy a skateboard. We begin with $45, and we save $3 each week. So that's important information. We're going to use our close reading strategies and circle that. The expression 45 plus 3w gives the amount of money we save after w weeks. How much money will we have after 4 weeks, 10 weeks, and 20 weeks? Is the first question, and then it asks, after 20 weeks, can we buy the skateboard? And explain. So here's how the book answers that question. It sets up a table, which is always a good idea when you're asked multiple questions like this. So After 4 weeks, we substitute in 4 for the W, so 45 plus 3 times 4, and when you do all of that math, you find out that you have saved $57. After 10 weeks, we've saved $75. So we're not quite up to our $125 that we need for the skateboard. And then after 20 weeks, we've saved $45 plus $60, which is only $105. So after 20 weeks, we have saved $105. So if you look over at the tag says we need to save $125. So we cannot buy the skateboard yet. Remember, to earn credit for viewing your flipped lesson, you need to complete your notes in your ISN, complete your on-your-own questions in your ISN, and submit them in Google Forms, and complete your Big Ideas math assignment in your math notebook and submit that when it is 100% correct. Remember to visit your teacher if you have any questions.